I'm also going to talk about I'm going to talk about restoration, which, if you talk to mine closure professionals, is profoundly different. Ecological restoration and mine site rehabilitation are not the same thing. And I should, before I start, acknowledge my collaborators, Carrie Wilson, who is at UQ with SEED, and Virginia Matzek, who was a visiting fellow at SEED 2 years ago now, from Santa Clara University in California. And mine site rehabilitation is about restoring a mine site to a safe and stable condition. Ecological restoration, which is what this research is about restoring a damaged ecosystem. So it's more about ecology through human intervention. And this research was motivated by the idea that ecosystem restoration can generate a variety of ecosystem services to people. So most of you, if not everyone, will have heard of ecosystem services, things like carbon sequestration, erosion control, water purification, a variety of services that can be generated through ecological restoration projects. And the idea is that these ecosystem services benefit people. And the premise of this research was that ecosystem restoration decisions, projects, are usually based on environmental deliberations. You know, we need to restore, we need to protect this species or this habitat because of the species and the habitat, without thinking too much about how humans can benefit from restoration. So Virginia came up with this project in the first instance, and she wanted to know, well, are these ecosystem services, this variety of ecosystem services, being considered in restoration projects in Australia? And she conducted a range of interviews with natural resource managers and regulators on how they determine which projects to fund and what ecosystem services they target. I am not going to present that in this talk. And then we did a survey of the public in Australia, on what ecosystem services, out of a list of potential services, are actually preferred. What disservices are experienced from restoration, also not something that I'm going to focus on here, although I do have the data if you're interested, and what's the public's willingness to pay for restoration projects. So we did an online survey, which was quite an impressive survey, I think. We reached we reached over 1,900 people, but some responses were invalid because they were actually overseas, so I cut those out. I have 1,869 usable surveys in this project. And the survey described, well, what are restoration projects? You can see the scenario on this screen. There is restoration projects all over Australia. They can have different goals. Some of them may focus on water conservation. Others may focus on restoring forests. Others may focus on protecting animal species. And what we're interested in is which of these services from restoration would you like to see most? And the survey started with a few general questions, and then we presented them with a restoration scenario. And the interesting thing about this restoration scenario that it was specific to the region that the person lived in. So we had about 16 or 18 different scenarios. And this is the one for Perth. So then there was also one for the Southwest, one for the Kimberley, one for the Wheat Belt, etc. There was one for each region in Australia, and it was made specific by the type of ecosystems that were presented. So they all included an endangered woodplant community, some familiar species, and some threatened species, and some other dominant plant species. So those are the ones that varied in each description. But the bottom half of the scenario was the same for each location. So we said that it might be possible to provide a whole range of benefits, such as the habitat for these threatened species, recreational access, carbon storage, harvest of forest products, benefits to farms, water supply, water quality. But there will be trade-offs between those services, is what respondents were told. And we then proceeded with a number of questions about that scenario. The first step was to do a best-worst scaling exercise. So best-worst scaling is a stated preference method. I think it falls in the non-market valuation sphere. So if you have questions about best-worst scaling, ask Michael. And the idea is that there are several types of best-worst scaling. We did a very simple called case 1 best-worst scaling exercise, where respondents were shown a list of, in this case, ecosystem services, and they were asked to indicate their best and their worst. So they each answered 5 questions in which they were shown 4 different potential services, and they had to drag their most preferred and their least preferred benefit. There's different ways you can set this up. This was our survey. If you have any clarification questions, you can ask me during the presentation, by the way. Now, there are different ways you can analyze best-worst data. The beauty, I think, about best-worst scaling is that you can simply count how often was something chosen as best and how often was something chosen as worst, and that gives you a score. And with the score, you can get a ranking of the most preferred service. You can estimate econometric models which have the added benefit of actually giving you a not just a ranking, but also the weight for each service. And I estimated a range of models from simple conditional logit models. I'm not going to show you any equations on how they work, but a standard conditional logit model. I also estimated several heteroscedastic models that account for difference in error variance, and random parameter or mixed logit models, I should actually say. Yeah, no, random parameter logit models, which account for differences in preference amongst the population. I'll show you the results later, because I want to go through the survey first. So after the best-worst scaling exercise, they then were shown, right, these were all the benefits that we just gave you in sets of 4. But there's 10, and which one of these, if you only had to choose one, which one would you prefer most from that restoration project that we described to you earlier? Because we told you there's a range of different benefits that could be targeted. Which one do you want to see targeted? And they chose one, and then we said, all right, you chose this specific benefit. Now imagine, we're going to implement the project targeting your chosen benefit, but we need funding. And some of the funding will have to come from people. Would you be willing to make a donation? And this is the intro to the contingent valuation question, which was the 3rd part of the survey. First, they said yes or no, I will or I will not donate any money. And if they said yes, they were shown a payment card. So just with a whole bunch of options from 1 to more than 500, how much would you donate as a one-off donation?
Do they have to actually donate?
No.
Okay. Do they have to?
No, it's not. They don't. No.
Do they know that it's just hypothetical? Or do they believe it's true for real?
I don't know what they believe.
Yeah, but you tell them.
Would you be willing to donate so that the site could be restored? That's all it asks.
So that looks like it could be real.
Yeah.
Yeah.
No,
Well,
it's not, because they're an online panel, aren't they?
yeah. Yes, it is an online
They're
panel.
going to be asked to actually defend your data.
I don't ever say in my choice experiments, this is hypothetical, so don't worry about it.
But I'm sure that quite a lot of people will, when they see this, say, okay, so they're going to come back to me, depending on how I answer it, and then, you know, they'll follow up on this and say, okay, you said you'd be paying $20. Can you please give us $20 now?
Well, although it does say if not enough donations are received, the project will not be implemented. So maybe that's when you think,
It's okay if they think it is really. You want them to give
yeah,
an
you
answer.
exactly.
Okay.
I didn't like having more than 500 in the survey because I thought, well, what's the upper limit? But there were only 2 people who chose that out of the 1,900 people, and I chucked those out. So they're not included in my analysis.
So the extent of the benefit, there is no information on that, like over what area or...
The area was specified, it was 52 hectares, I think it was. I can go back to the scenario if you want. Oh, 152 hectares. And it was, yeah.
So whatever money they're paying, that's for that 150.
Yeah. One of the benefits could be jobs, education, training. Yeah. Analyze that with interval regression models because it's a payment card. We only have a range. We don't have a precise willingness to pay. But let me go to the results. Firstly, the choose your preferred benefit out of the 10 shown options. What you see is that most people preferred biodiversity-focused benefits, which are protect threatened species or provide bigger or better habitat for native plants and animals.
These are numbers of people.
There's numbers of people who chose these. So the vast majority chose biodiversity. I have the human-focused benefits in purple. They're not chosen very often, except for jobs, training, and education. So another way to find out which ecosystem service people prefers is this best-worst scaling exercise. So I estimated several models. I'll go through those. This is just a simple conditional logit model. So that assumes that preferences are the same across the whole population. And best-worst scaling is done based on one relative to one ecosystem service. So you can, in this case, there were 10 services. I estimate the model on 9 of them. The reference in my model was carbon storage. It has an estimate of 0. Everything above 0 is preferred relative to carbon, and under with a negative estimate is less preferred than carbon storage.
Is there any particular reason why you chose carbon storage as your benchmark?
Because all the coefficients were significantly different from that one. I think if I chose recreation, there was a large standard error on these two, and so they were not actually significantly different. But that was the only ones that were not significantly different. What you see is just like in the ranking, the rating, the choose your best exercise, the biodiversity benefits were most preferred. Although, actually, I just noticed the typo here. The water quality and habitat is pretty much on par. What else? Those human benefits are least preferred. So they match up with the earlier rankings.
It's interesting with jobs, training, and education.
To go back to how water quality has changed. Where was water quality on the bar chart?
There you go. This was the previous ranking. So that was the ranking that I had on the bar chart. And you can see that it's slightly different, not very much different. The most important changes is that jobs and training has, from a relatively high score, gone down. And soil improvements has gone up. So if jobs training go down, water quality has gone up. So one reason that BWS is used is because it provides this ranking. And I'm seeing that this actually, it provides different outcome, which could be, I'm not sure if that's concerning. Maybe it's not, because if you choose your most preferred, that's different from choosing your most preferred and your least preferred. So I might actually expect best worst to yield a different outcome. So what if I analyze the model on just my most preferred option? If I do that, there's only one change, and that is that water supply and jobs and training swaps position. Everything else is the same. So it's again not the same ranking as choosing my one most preferred option. It's a little bit different than what other authors have found in
so the 0.23 and the 0.29 are different from each other in model coefficients 1. So they're estimated very precisely.
Yes.
So that
Yeah.
Okay.
Yeah. The standard error on the these estimates is very small, but I'll show you the standard deviation in a bit. They can be quite large. So let's first focus on that result, that the ranking and the best worst is different. That might be because of a framing effect. If you have a best worst, in the best worst scenario, the choices were just four services of which to choose your best and your worst, whereas in the choose your one best, you had all 10 available and you could only choose one. So it might just be a framing effect, or should I be worried about my data set? Is another option. But another framing effect that I was interested in is that there could be a difference between when people choose their best versus when people choose their worst option. So your most preferred and your least preferred. And prospect theory would suggest that yes, there will be a difference between most and least. And when you look at the literature, several best-worst studies have now been estimating heteroscedastic models that account for differences in error variance between the best and the worst choices. So I did that as well, and yes, I find that there's a difference in scale. In fact, people, when choosing their best, have a smaller error variance than when people choose their worst, which could indicate that choosing your least preferred is more difficult than choosing your most preferred. I'm still a bit uncertain about all this, so if I make a comment that is that sounds weird, then just ask me.
If the variation is smaller for the best choices and for the least choices, rather than if you had the opposite, I would expect there to be less of a difference between the results by using best and worst and only best. Right? So there still is a question mark there.
What? I don't understand the question.
Okay, you say there's a smaller scale effect that you're saying basically it's more difficult to make choices for the worst choice than for the best.
Mm-hmm.
Okay, and then at the same time,
I said smaller scale. I mean smaller variance.
Yeah,
yeah.
Whatever. And you're saying that there's a mismatch for some of them between these two ways of measuring this. So I'm just trying to, asking myself, don't quite get that.
I don't think those two are related. The fact that the best, estimating a model on best only, and the choose your one best, the fact that those are different, I would hypothesize is more because of a different question frame, potentially, but I'm open to suggestion.
Is there any literature that actually looks at this at all?
I haven't finished reading all the literature yet.
There's nothing different, really, though.
That's what I'm pretty. So the worst doesn't actually give you that much extra information, but I would have thought.
And that's exactly what this is about, because best-worst scaling is often proposed as a way to get more data from the one respondent, but it actually might not even be useful. Katrina did a study using best-worst scaling, and actually because of the difference decided to only use the best, which means you're putting respondents through an exercise without actually using their answer. But, sorry James, you were not finished.
No, I was just saying, so I agree with Dave. I would have thought that those things are telling you a pretty consistent story. A few things bouncing around, it's no big deal.
Rankings are very susceptible to small changes, potentially.
Okay. Oh, that makes me feel a little bit better. Although Michael's going to say something now.
Can you combine the best and worst once you're accounted for scale?
Yes, I'm going to go.
So that would be
Because you can account for scale. But what I also did, and I only found one paper that has done this, is looking at, well, there's papers that have accounted for difference in scale, but what about difference in preferences? So you can estimate a model. So I'm not showing you any model results because it's just tables and tables full of numbers, but you can have two separate sets of coefficients, one for the best, one for the worst. And when I do that, yes, I also find significant differences in terms of preferences. Except for the jobs and the forced harvest products. Now, when I account for scale, there is still the significant difference. However, I need your help, because I think I need a different program, because Stata cannot estimate a model, a scale heterogeneity model, with diversion in the scale as well as in the preferences. I kept getting error messages no matter how I coded it. So that might be. So, but I then accounted for difference in scale because caused by like male or location. Yeah.
Could you just clarify a little bit, what's the nature of the difference that you're picking up there? You've got a difference in preference estimates between best and worst. What is different?
Just the extent to which someone prefers again, the ranking is the same, but the weight that people put on their most preferred and their is different than when you swap it around and ask for their least preferred.
So there's the coefficient on the reference.
Yeah.
And that is different between best and
Yes. Yeah.
But the ranking is similar.
Yeah.
the rank.
Okay.
But there is a way, and again, it's work in progress. One thing I haven't figured out yet is you can calculate the scores, the population scores, based on best-worst coefficients, but I haven't figured out how to do that yet. So this might be interesting for all PhD students. Don't worry, we don't know everything either.
Maybe present at business school and they will give value.
Oh yeah, they will shoot me down. They will shoot me down if I present something like this. Okay, just quickly, I also estimated random parameter logit models, and apologies, I am putting up a table for that one. Again, carbon storage is the reference. The benefit of random parameter models is that instead of assuming that you have consistent preferences in the population, is that you allow for variation in preferences between individuals. So you get a mean coefficient estimate, which I had before, but with a standard deviation, which is the variability in the population, or no, the variability in the sample in the preferences, in their preferences for these restoration surfaces.
Relative to carbon? Because you've got zero carbon. in this thing.
Maybe I should have said that. No, I just put that in, but maybe this is just empty. Yeah. I put a 0 in, but it's just empty. So there's no estimate for carbon.
So, can you just walk us through the first row there? So what does that mean that there's a small proportion of, do I read that and go, if I go two standard deviations down, that's the proportion of the people that would have a negative coefficient for protecting threatened species? I just don't know how to read the table.
That is technically what it says. So how I interpret, with choice experiment it's much easier, eh? Because then people could have a negative value for things that you show them, a negative trade-off. So my interpretation here is that at the top, the things that people really, really prefer the standard deviation is relative to the coefficient, relatively small, compared to when you look at the bottom things, the things that people not like, or not prefer, I should more say, where the standard deviation is a lot larger than the mean coefficient. So here it just says, what this says to me, walking through an example, is that farm benefits are in general disliked, maybe I shouldn't say disliked, but less preferred than carbon. However, there is a large variation in the population, which means that some people prefer it much more than carbon and other people prefer it much less. Whereas if you go to the top, protecting the threatened species is, on average, preferred most, and then the standard deviation tells you, okay, there's some variability, but not nearly as much as for those less preferred restoration services.
Maybe that people are really, for the top ones, they consistently, these are really up there, what really interested.
Yeah.
The bottom ones, a bit more uncertain, that I don't really know what a farm benefit is.
Okay, so
They actually were described in the survey, but yeah.
I'm just getting a lot of, there's more variation in my relative rankings down at the bottom, because these are just less prominent in my head. Species, water quality, habitat, yeah. These other things, when I'm answering the questions, I could be slightly more all over the place.
Yep. So it's not inconsistent. It's as I would expect.
So for farm benefit, for protecting certain species, the variation actually the same.
Yeah, but it's relative.
Yeah, but it's relative to the mean estimate, eh?
Yeah, but then that'll
And
depend on
just
which
pick-
one you use as your reference one.
If you pick habitat for plants and animals as reference, your coefficient would change it, but your standard deviations will not.
That's right.
Yeah.
Yeah.
But then-
and the standard deviation for the protected, for the first one and for the farm benefit are the same.
I'd have to try. Yeah. Okay.
I'm not sure the
And
standard
not
deviation
sure if
will
that's-
move.
No, they will not go.
Right. Can we save that? I'll send you an email whether it will or not.
Yes.
Set habitat as your reference one. And
Yeah. Exactly. I'll do that. Yeah. Oh.
Well, wouldn't you make sense to set as well, like set the lowest one, like solve it, put the lowest one, and then you have a clear, yeah, like.
Yeah, I've done it as well. It doesn't.
The question is what happens
I think
to the standard deviation.
I think
Doesn't really
that these
matter.
results show the polarization in people's views, though, is that you have some people that are going to be valuing, well, they do value protected and threatened species. That you have some people that a subset of people that are valuing, because that's all of the human, all
Yeah.
the human related ones, that they're going to be valuing them very highly.
No, actually, when you have to keep in mind that bar graph, where there were a lot of people choosing protected, threatened species and habitat as best, but only very few here.
Sure.
Yeah. But I'm going to
That was
continue.
absolute best.
Yeah,
right?
yeah,
So
that was
there's a
absolute.
whole-
Yeah.
There's a whole thing going on here.
But if you look at the best worst counts, that comes back in here as well. I'm just going to continue and save the rest of the discussion until the end, because I just wanted to flag the contingent valuation results as well. So this is this interval regression model that I estimated. This is average age, average income, having a university degree, being from New South Wales, being a man, and some other things. I'll walk through them. First of all, I have less respondents because there were a lot of protesters and a lot of people who said, I'm not willing to pay. Remember, we asked for a donation, so there's a lot less.
What happens to all the zeros?
There was people who said, I'm not willing to pay. They were asked, well, you're not willing to pay because you don't value restoration, or because you don't have the money, or because you don't like our survey. So anyone who had a valid reason for not being willing to pay is in here. So they're all zeros. But protesters are excluded. And there were a lot of those. A protester is someone who says, I like restoration, but I don't like your survey. I like restoration, but I don't give money to charities. I like restoration, but I don't trust that this project will be implemented. I like restoration, but I don't believe your scenario.
So aren't they real people in the real world? Aren't they real people's views?
Yep. So that's a debate you can have about including or excluding protesters. The result will be that the willingness to pay will go down, but it's about it's data. It's a data management, and like I said, it's a debate on whether to include them or not, which is not part of this of the paper that we wrote here. Because they're real people, but yes, exactly. I was just about to say that.
That's not true.
Hang on, I don't follow.
Because
Well, you don't know.
love the environment, and you value it highly, and you would love to protect it. You just don't want to give the money to the government to do it, because the government will try.
So Michael, can I respond to the question on my study? So what we wanted in this survey was to gauge people's values for ecosystem restoration. And because we were after an indication of value, we said, okay, protesters are out. If we would have used this as a tool to estimate, okay, what's the average contribution in terms of money that people would want to make, then I agree, protesters, and that's a debate we had many times with the author group.
It's actually quite an interesting point, isn't it? If you look at the differences between the two, it gives you some idea of the importance of those other aspects that would prevent a real program from happening that has got nothing to do with valuation, right?
Yeah. So I did this work with two ecologists, and there's already been published so much work on whether to include protesters or not and what the differences are. We thought it's not going to be that interesting to stress that again. I mean, the values go down if you include protesters. And on that note, maybe don't look too much into those numbers, but what you can see is that men are willing to pay more. That is interesting because it's different, but most of the protesters were men. So a lot of men fell out of the sample. So we have the green men in this.
Sorry, can you just, so I add, the male is not solving for male,
Yes.
I add...
Men are willing to pay $5 more on top of their average.
Okay,
yeah. Per extra, so the average is 7.6. Every year that you're older, you are willing to pay 18 cents more. Income, every $1,000 more per year is 12 cents more or less. So this is in addition to the average. If you have a university degree, you're willing to pay $7 more. If you're from New South Wales stood out for some reason. But the more interesting note that I want to finish on is that their preferred service actually had an impact. So that out of the 10 services, which one do you prefer most? I tested, and the one that came out as significant was wanting to target threatened species protection. Interestingly, I think I have that, interestingly, the habitat one did not show up as significant, which I thought was a bit weird. We also asked about these services, what things don't you like about restoration, and people who said that restored forest will take away farmland out of production were willing to pay less. So what we want to use these results for is not saying, okay, people are willing to pay $5 less, but helping it to target conservation management scenarios and outreach.
Were all the threatened species you used charismatic species?
I don't know. I don't know how to define charismatic species, but they were all
furry, typically furry, mammals.
No, there were birds as well in there.
Oh, okay.
Yeah.
But no fish, no invertebrates.
No. But also, protecting threatened species was just a statement, right? There weren't any examples. other than in this scenario.
The base there, the preferred to the species.
Sorry?
The base, like what do you compare? This 5.73
That's
compared to what?
to the average. So those people were willing to pay $5 more than, so they were willing to pay then, how much is that? 13, 12, about $13 compared to 7. So just quickly, some conclusions, although we've been through everything, is that in terms of most preferred ecosystem service, people like biodiversity benefits rather than other type of benefits most, which on the one hand you might expect, but on the other hand that contradicts the whole idea that ecosystem services and restoration co-benefits are really important to get people on board. That's apparently not that important as we may think, at least for restoration.
No, this is one of ecosystem services.
Yeah.
So it's important. Co-benefit maybe not, but this ecosystem service is just like.
See, I see some ecosystem services as.
There are some and there are other. Everything you can classify into ecosystem services.
Right.
So
So you mean co-benefits? I shouldn't call it co-benefits. Okay.
We'll call them non-ecological benefits.
Yeah. Okay. Anyway, that might be useful if you want to promote restoration. Also, from a methodological conclusion, that this BWS gives a different ranking, slightly different, and there's also a difference between best and worst choices, which I might expect because you choose your most and your least preferred. It's a completely different question, which I think BWS studies should really consider and report. And not everybody does that. Not everybody checks that. They're willing to pay for restoration. They have in light of James' comment, I should probably change this to respondents have a positive value for restoration, and those who prefer protection of threatened species have an even more positive value, which as maybe you could use that in outreach, which also is as expected, and it confirms findings in other studies that if you promote restoration in terms of we're going to protect species, and I have chosen cuddly species here in this picture, then you might gain higher support for your restoration project. And I'll stay there. Thank you very much.